what do those words mean, parallel and perpendicular? What do they mean? When I say two things are parallel? Yeah, so straight's not probably a really specific enough term. I know what you're getting at. Let's try and think about a good way to express it. Jake?
Never meet?
Yeah, that's right. That's perfect. So parallel means they never meet. Okay, two lines that are, I guess, headed in the same direction, they'll never get closer together or further apart. And that means their two gradients are the same. Now you've got to be careful with that, because there's actually one case where two lines can have the same gradient and not be parallel. It's actually where they are collinear. It actually means they're the same line, but just written in different form. So it's kind of not true to say they're two lines, they're just the same line. But you can have two equations that look different, that you find out as having the same gradient, they could actually be the same line. So that's just a little thing to be careful of to make sure they're not collinear. But if we're saying, in a general sense, two lines that have the same gradient means they're parallel. Now what about perpendicular? What does that mean?
Halfway through, so like an X.
Yeah, so again, let's be more specific. Something else?
They can become closer together the further.
Yeah, well, that's true. But something in particular about perpendicular? Because any lines that are not parallel...
Right angles.
Sorry?
There's right
angles, that's perfect. All right. So perpendicular lines means they meet at right angles. Or they may not even meet, but they are at right angles in terms of their direction. The way to test it is you multiply the two gradients together, and if they equal -1, they're perpendicular. Or if you know one gradient and you need to work out, well, what gradient would be perpendicular to that, you use it in this form, m1 equals -1 over m2. All right, you put, in fact, it's probably better to write this way, then. I'll go 2 over here and 1 here. Okay? You put -1 over the gradient you know, and that's the new perpendicular gradient. And so it's good just to know this is a way of testing, and this is a way of calculating. Test using that one, calculate using that one. So we're going to put that into practice now. We're going to calculate two lines from this equation, one being parallel, one being perpendicular. And so, taking this one, find the lines parallel to and perpendicular to this through the point 1, 2. So we're going to say, all right, I know that line and I know the gradient of it, and if there's a line that's parallel through that point or perpendicular through that point, what are the equations going to be? So let's take it one by one. Let's do the parallel one first. We'll rub this off. I'm going to rub this off here. Just give some more room. Alright, let's go over here. Let's work through some parallel. I need to know what the gradient is so I can use that. We didn't actually specifically calculate the gradient of this, so let's do that now. Have a look. I wrote on the board before, if you wrote it down. How do you work out the gradient from the general form?
The y-intercept. I mean
Y.
Can't you just put the y on its own?
You can,
and then
but that involves moving the whole thing, but what's the quick way? Minus over b. That's what I wrote before, gradient is -a over b from this form. So our gradient of this one equals -9 over -5, or just 9 over 5. Okay, so that's our gradient of that line. So just that's a quick way to work it out from the general form. You can rearrange it, yes, but that's just a quick way to do it. And so I've got a gradient and a point. How am I going to work out an equation from that? I've got a gradient and a point. What do? I spoke about it up on the board about 5 minutes ago.
You do a negative one?
What do you mean by that?
Are we doing perpendicular?
No, we're doing parallel at the moment.
Oh, okay.
Yep, so I've got I want the parallel line through this. So I've got a gradient, I've got a point that it goes through. What formula am I using?
Point gradient.
Point gradient. What is it?
X minus x1. No, y. y1 minus y.
Y minus y1.
Yeah, and then equals m brackets x minus x1.
Just, you said y1 minus 1 first of all. Just as an aside, if you did y1 minus y and x1 minus x, it actually would still work out okay.
Yeah.
As long as you have the same pattern in both.
Yeah.
It's much easier to use this one though.
Yeah.
You've got positive y's and x's straight up. Okay, so we plug it in. What am I writing? Dale, what am I writing?
Y minus 2 equals m,
What's it?
9/5.
Yep.
And then brackets x minus 1.
Minus 1. Awesome. Okay, what's my next step? It's a little bit more awkward because we've got fractions and stuff. What do I do? How am I going to write this in a way? Let's say now, I'm going to tell you, let's put it in the gradient intercept form. Okay, the y equals mx plus b form.
Y equals 9, that same thing, then minus 2 at the end. No, plus 2, sorry.
Yep.
And
a bit
then
more work though.
can you times the middle, the brackets by 9 minus 5?
Yep, so what do I write?
9/5, yeah.
Like that?
Yeah, and then negative 9/5,
Yep.
yeah. Y equals,
Y equals, same thing.
yeah, and then just add
Okay, put that
19/5.
Y.
No, not that.
So it's negative 9/5 plus 2. How do we deal with that?
You don't.
We do.
Isn't it plus 0.2?
You timed everything.
Yeah, that's a decimal. Let's think about it in fraction though.
Yeah, well, 1/5.
Yeah. And so let's break that up. You're right, 1/5. What are we saying here? So it's minus 9/5 plus 2. Let's write that as an equivalent fraction. So 10/5. And it's minus 9/5 plus 10/5. So over the denominator, minus 9 plus 10 is just a plus 1. So plus 1/5. Okay. That's my point, that's my gradient intercept form of the line that is parallel to this one through that point. Fantastic. Excellent.